Hi, everyone. We're going to talk about the structure of the Earth's atmosphere using a virtual interactive that Glencoe has put out. It's also linked into your Blackboard account under target number 3, Properties of the Atmosphere, on our Unit 3 Atmosphere tab. So I'm going to kind of show you how this virtual lab works or virtual interactive works and kind of go through some of the information that you're going to be responsible for on the test. So if I look at this particular interactive right here, you can see that we're starting off down here at the bottom at sea level. And then as you go up, you're going to go into that layer of gases and dust and liquid particles that surrounds our planet known as the atmosphere. So on this side, you can see that this is showing altitude. How high above the ground are we getting? And so on the side, you can see that we have our layers of the atmosphere divided up. So we have the troposphere where we live down here at sea level. Above that is something called the stratosphere. Above that is the mesosphere. Above that is a layer known as the thermosphere. And then finally, you have the layer that is known as the exosphere, which oftentimes is thought to be a part of the thermosphere, but it's that outermost layer where we see the boundary between space and our atmosphere kind of being meshed together. There's not an actual definite line that says now you're in the atmosphere or now you're in space. So if I were to launch our weather balloon right here, reset, and I'm going to move up to about 10 kilometers above the ground. I'm going to launch that weather balloon and see what happens. Okay. You can see that the weather balloon went up into the stratosphere, almost into the mesosphere, before it had so little pressure on it that it was able to expand and actually burst. But what I want you to notice is that at the top of this troposphere, notice that the air density is 33.6, the pressure is 26,499, and that the temperature is actually negative 50. So if I go back and reset this, you can see that the temperature was 15 degrees and it went to negative 50. So in the troposphere, the temperature actually will decrease. The pressure here at sea level is 101,300 pascals, which is incredibly more than what it was at the top of the troposphere, and that the density here is 100%. So the density and the air pressure as we went up actually decreased, and the temperature decreased as we went higher in altitude. So now I'm going to move this the altimeter, I guess, to the top of the stratosphere and see what these measurements down here of density, pressure, and temperature does. All right, so our rocket made it up to the top of the stratosphere. And if you notice, we ended at the troposphere at negative 50. But now we're at negative 2. We actually increased in temperature. So as you go higher in the stratosphere, you're going to increase in temperature, mainly because the stratosphere has a specific layer within it known as the ozone layer. And ozone is a greenhouse gas that absorbs a lot of the Earth's energy and radiates it back towards the Earth's surface. So this area stays a little bit warmer because of that layer. So as you go higher, the temperature increased. Notice that the pressure is much less than it was at sea level, and the density is much less. It was 100% at sea level, and now it's only 0.09%. So as you go higher, the pressure and the density both decreased. I'm going to reset this. Remember that we stopped at negative 2 for temperature-wise at the stratosphere. Let's find out what the temperature is like in the mesosphere. Notice that the temperature began to decrease again. It went to negative 65. The mesosphere, just like the troposphere, has the temperature pattern that as you go higher, the temperature is going to decrease. Pressure once again has decreased and density has decreased. That pattern stays true. The higher you go, the less air density there is and the less pressure there is. And depending upon what layer you're in, you'll see a different temperature pattern. And finally, we're going to go up to the top of the thermosphere. So we're going to move our altimeter up to 400 kilometers high. We're going to launch. Notice that the temperature has begun to increase, the pressure once again has lowered, and the density has lowered. So as you go higher in the atmosphere, the density and the pressure will decrease, and the temperature pattern depends upon which layer you're in. The troposphere and the mesosphere get colder the higher you go, whereas the stratosphere and the thermosphere actually get warmer the higher that you go. So this reviews the atmospheric properties that will be tested on your upcoming test.